To start this problem off, since we're given the coordinates of the vertices of triangle ABC, I've gone ahead and labeled them in this Cartesian plane. So for the first part of this problem, we are being asked to prove that that triangle is isosceles. Remember, an isosceles triangle means that two of the three side lengths are the same. And by looking at what we drew, you can kind of tell that the two sides that are going to be the same length are AB and BC. So what we're going to do to prove that they're the same length is to use the distance formula. We'll start with the length of AB. So it's going to be the square root of, and then in brackets, remember we do x2 minus x1 squared. So our x2 is the x value of b, so it'll be -5, and then minus x1, which is +1, that'll be squared. And then we'll add y2 minus y1, so that would be 3 minus 2 squared. That works out to become the square root of 37. Next, we'll do the length of BC. So that's going to be the square root. And then now we're going to do x2 minus x1, where x2 is the x value of our C point, so it'd be -6, minus the x value of B, which is -5 squared. And then we add y2 minus y1. In this case, that would be -3 minus 3 squared. And of course, that also gets us an answer of root 37. We can then conclude that since AB is equal to BC, the triangle ABC is isosceles. Great. So now we can move on to part 2 of the question. It says to state the coordinates of point D such that quadrilateral ABCD is a square. Well, to figure that out, let's zoom in a little bit here. For this to be a square, one way to think of it is that the distance from B to C, we would want it to match from A to D. So because to get from B to C, we move 1, 2, 3, 4, 5, 6 down and 1 to the left, we would do the same thing from A to D. So 2, 4, 6 down and 1 to the left, and that gets us to this point, which is 0, -4. Now, moving on to the last part of the question, we are asked to prove that the quadrilateral ABCD is indeed a square. Now, in order to do that, there's a couple things we need to do. First of all, we need to show or prove that all four sides of the square are the same length or congruent. The next thing we'll need to show is that the consecutive sides are perpendicular to each other. In other words, we're going to do that by showing that their slopes are negative reciprocals of each other. So let's start by proving that all four sides are the same length. We've already got a head start on that. We've already shown that AB and BC, the length of those is root 37. So our next step would be to show that the lines from A to D and C to D are also the same length. Let's start with the line AD. Using that same distance formula again, it's going to be the square root of 1 minus 0 squared plus 2 minus -4 squared. And of course, that works out to root 37 as we expected. And then to find the length of CD, we'll take the square root of -6 minus 0 squared plus -3 minus -4 squared. And that also gets us root 37. Next, let's focus on proving or calculating the slopes of these lines. I'm going to do that over here. Let's start by looking at the slope of our line from B to A, or AB, I guess. So the slope of BA. And remember, the slope is our change in y over our change in x. So from B to A, the change in y is a distance of -1, and change in x is 1, 2, 3, 4, 5, 6. So the slope from A to B is -1, 6. Now let's look at the slope from B to C. Let's move over here. So the slope from B to C, well, the change in y there is positive 1, 2, 3, 4, 5, 6. over the change in x, which is just 1, or in other words, just 6. All right, so let's move back over to the question, bring that all in, and now I think we're ready to write our conclusion. So I've written out that ABCD is a square because all 4 sides are congruent with that length of root 37. The consecutive sides are perpendicular since the slopes are negative reciprocals, and we've proven that. And therefore angle B is a right angle because those are perpendicular lines. All right, and we are done. That's all for this video. Thanks for visiting JD's Preparation.